All right. Good morning, and thank you for being here. My name is Todd Wagner, and I'm the Project Manager and Water Resources Engineer with Vector Associates. Today, the team is here to discuss our progress on designing the Crown Point Business Park. In order to effectively communicate this progress, we've broken up today's discussion into 6 different parts. I'm going to give a brief project overview to remind us what exactly we're building. Then each one of our engineers is going to have an opportunity to share what we have designed. And finally, there will be a period for questions and conclusions. So to start with, we've been gifted with an agricultural lot. And on this lot, to develop it, we have to design a roadway, drainage for that roadway, and then there needs to be a multi-use structure on a parcel of land. And finally, there needs to be water resources BMPs to treat water that fall on this lot. I'd now like to hand it off to our transportation engineer.
Thank you, Todd. My name is Leah, and I am the transportation engineer here with Vector Associates. I'm going to refer to all the work that I did previously last semester as my phase 1 work. So last semester, I will show in just a minute, but I created an alignment for a roadway from Maryville Road to North Indiana Avenue, and I also created a lane configuration for the southeast intersection, which I will get to in a little bit later. And I'll walk through my phase 2 work this later on. So my previous work of my alignment is just under a 0.4 mile length roadway that spans in an S shape from Maryville Road to North Indiana Avenue. And we have designed it at a speed of 30 miles per hour. And for future reference, we will be developing a parcel over on this northwestern edge. And for the southeast intersection of North Indiana Avenue and East Summit Street, I have developed an alternative for what is currently there. Currently there is a through and right lane combined in a left turn lane. So at all approaches, I separated those into a separate right turn lane, through lane, and left turn lane. By separating all of these, each approach has a level of service C, which means that when a vehicle approaches the intersection, they won't have to wait for more than 30 minutes. So about 29 seconds they'll only have to wait, which is better than what it was currently at a level of service E, which is about a 2-minute wait. This is the aerial view of that said intersection layout. From previous phase 1, you might have seen that it was shifted southward, but now it has been shifted northward in order to not acquire as much of this property. Last time, the road went right over this building, and we thought in order to make our neighboring property happy, we should scooch it northward and invade more of our property and the nearby parking lots instead of taking over a whole building. The typical section for my roadway is developed using the City of Crown Point technical standards. It has 12-foot wide travel lanes at a 2% slope, as well as sidewalks on both sides of 5 feet wide. And there is about 14 and a half feet between travel lanes and sidewalks, which allow for adequate space of curb and gutter drainage facilities, which will work in tangent with my environmental engineer. I created a profile for my alignment, keeping the high points and the low points at the same places they currently were with the existing roadway. It is hard to see on this, but the blue line is my proposed and the green is the existing roadway. And so by keeping the high points and the low points the same as the existing ground line, this allowed me to work better in tangent with the environmental engineer and keep their work consistent from last semester. The majority of my work this semester has been on my parking lot design. When we were figuring out how many parking spots we needed, we turned to the City of Crown Point zoning ordinances, and we found that we need 193 parking spots, which is larger than the 2 groups I presented earlier. But just to remind you, our mixed-use commercial building is both retail and commercial. So we need about 170 square feet per space, per parking space, and when you include all of those and the travel length that it takes to maneuver around the parking lot, we need over 2 acres of just pavement alone, which is a lot of pavement, and which also runs into a current problem because our current acre on that northwest side is only 1.88 acres. So we were faced with a dilemma. And how did we approach this? We came up with 3 alternatives. Our first alternative was to expand, to buy more property either adjacent or south of our current parcel. This would allow us to create what I am calling a mega parcel, which would allow us to expand and also place the structure, and our water resources engineer would only have to expand the BMPs instead of having to create a whole new site. The second idea was to construct an above or below ground parking structure like you can see in downtown Valparaiso or even in Indianapolis. We quickly ruled this one out based on the skill set of our engineers and also just the feasibility of it. And the last one would be to contact the city of Crown Point and ask for an exemption to have less parking spaces required. Our current our current parcel of 1.88 acres could only really hold about 70 parking spots. So we'd be asking for an over 50% deduction. We thought that'd be a too large of an ask. And by staying in scope, we decided to buy more property, or I guess acquire more property. So I drew out 2 new parcels, parcel 2 being adjacent and parcel 3 being south, and they're both a little under 2 acres each. But we decided to move forward with parcel 2 as it would create better design work for our current water resource engineer, for them just to expand the current work instead of having to create new work, as much as having to create a brand new layout down here, as well as we thought pedestrian safety would be an issue. If you park south of the road and then have to cross it every single time, that would become an issue, especially with safety, and that's just not really feasible. So the majority of my work was designing this parking lot. It took a lot of iterations. I think this is like the 5th iteration of this design, actually. But we have developed 194 spots, which is one over the required needed, and that has 6 ADA approved spots. Those are indicated in the blue and white, with the white being aisles and the blue being spots. And there's also space on the sidewalk in front of that red structure for bike racks per guidance of the zoning ordinances. As well as you will notice, it might be hard to see, but there is 2 entrances and exits to the parking lot, and 90-degree spots allow for 2-way movement, and so there could be a lot of different movement. The thought here is that a truck could come in like this, and then turn right here to unload. And what I have moving on forward is looking back to my alignment more specifically and figuring out the lighting and signage needing along my roadway for different time periods to also alert the drivers. And then also, when all this construction takes place, there will have to be the traffic flow in a different way. So having to figure out a detour plan, and also finalizing my cost estimates. Last phase, I was brought up with an issue of having a really large sidewalk cost, so readdressing that and figuring out how to approach that going on, and also helping my group with the print sets from our AutoCAD drawings. Thank you, and I'd now like to turn it over to our environmental engineer.
Hi, I'm Maddie, and I'm the environmental engineer for Vector Associates. My scope for this project was to create a gravity flow pavement drainage system along the proposed road that Leah has created. This includes both collection and conveyance components that I have selected from last semester. I'll then be doing hydraulic modeling in PC Swim to verify my calculations and ensure that all of my components are within regulations for Crown Point and following Act 22. The alternative that I selected for the collection component were grate inlets. This is just a manufacturer's schematic of a component that is allowed by the city of Crown Point. So I've used these specifications and dimensions in all of my inlet calculations and design. Here is an overall plan view of my inlet design. So all of the inlets are the little green boxes along the road. They are placed so that during a storm event, the spread of water across the road and the depth of ponding at the road do not exceed maximum allowable levels. This is to ensure driver safety and so that hydroplaning or other such events do not occur. Some things to note along this road: there is one local high point that creates a drainage divide. So water is flowing to 2 local sag locations, and at these locations, because there is clogging assumed at the grates, there are actually 2 grates at each of these sags instead of just 1 grate to ensure that the necessary amount of water is intercepted. There is also a drainage divide created by the crown of the road, which is why you see there are inlets on both sides of the road and not just on one side of the road. My conveyance system is a concrete sewer pipeline. This is placed within the current road right-of-way, and all of the manholes are placed outside of the actual road. That way there's no additional easements that need to be purchased, and nothing needs to be shut down during any maintenance events of the sewer. The manholes are placed at any change in direction, slope, or diameter of the pipes, or at any straight locations less or no greater than 400 feet apart from each other. This follows a similar flow path as the inlets and the grade of the road. However, just for ease of maintenance, there is only one convergence point of the sewer versus the 2 side locations for the inlets. This is the manhole casting that I have gone with. This is just a standard drawing from Crown Point. Because all of my pipes are up to 24 inches, it just has an inside diameter of 4 feet. And then this is an overall profile of my drainage system. Again, you can see the convergence point along the, towards the end of the system. All of my calculations were done using the proposed profile for the road. So that is the red dashed line, or the blue, I think it's the blue line. The pipe slopes, diameters, and all the placements are done to maintain multiple things. One, the energy grade line cannot exceed the ground elevation. This is to prevent surcharging and water escaping the manholes. The flow within the pipe has to maintain a self-cleansing velocity, but it can also not be too high. And the pipes have to have adequate ground cover because they are underneath the road and there is a load applied on the pavement. So all of my pipes have a diameter ranging from 12 inches, which is the city minimum, to 24 inches at my biggest pipe. My next steps are to do my system modeling in PC Swim. This is so that I can confirm all of my hand calculations or make any alterations that are needed, and so that I can model the energy grade lines and hydraulic grade line for my system. I will then be finalizing all of my drawings and including the inlet connections along the pipeline, and then I'll be doing a detailed cost estimation for the construction costs. I would now like to hand it off to our structural engineer.
I'm Emma Hickey, and I'm a structural engineer here at Vector Associates. My first step for the scope is to produce a more improve the structural design of this. So this includes finalizing the location of the columns, the beams, and the girders. My next step was to add the gravity load, like the decks and the areas for the dead and live loads. After that, I will be adding the lateral loads and placing bracing where it is needed for the wind. And my final step is to produce a more accurate cost estimate. So here is a recap from phase 1. I had chosen to continue to work on the 2-level steel structure with the commercial use on the first floor and the office use on the second floor, as you can see on this side. And then over here is a very preliminary drawing of the structural layout. The beams are spaced either 10 feet or 12 feet, just because I followed a rule of thumb. That has changed now. But moving forward, the only thing that's still consistent with this drawing is the location of the columns. So Recent Floor helped generate a structural layout of this floor plan, and then I replicated it in AutoCAD so that I could show you it with the dimensions included. The beams are spaced either 8 feet, 10 feet, or 8.5 feet because I placed a concrete deck on this, and the concrete deck, the recent floor, so the concrete deck's thickness is 6 inches, and that it has a maximum span of 10 feet. So these are where the beams are spaced now. It is important to note that there are now spaces left open over here. This is for the stairs and the elevators that are very necessary for this. I placed them here because I wanted each office to have its own set of stairs and elevators, and then it's facing the parking lot that our transportation engineer mentioned, so that the office workers can get upstairs without having to enter the commercial space downstairs. The concrete deck is also important because now it can withstand the self-weight of the materials above it and the live load of 50 psf from the office above it also. Here is the structural layout of the roof plan. I chose to place a metal deck on this one because it only had to uphold the snow load of 31.5 psf and then its own self-weight. The metal deck, however, does require the spacing of the beams to be less than 4 feet apart instead of 10 feet. So in an effort to keep it symmetrical or have a pattern, the beams are spaced either 3.75 feet, 4 feet, or 3.78 feet. There are now beams placed where the spaces were once left open because obviously we do not need stairs and elevators going to the roof floor. So there are a lot more beams in this structural layout, but yet it is still encouraged to use a metal deck rather than a concrete deck because it is just not as heavy, and then we can choose to use lighter or smaller beam sizes. Now, after adding all the loads and the decks, RISA answered with these W shapes. I was able to perform hand calculations to check the shear, the moment, and the deflection of these beams. One beam that I did check is labeled as PUR 79, and it is right about here. I found a very similar shear and moment that RISA also found in the detailed report right here. So that's a good thing. That means that my load combination matches the same load combination that RISA used. And then it said that this member was a W18 by 40 shape. So when looking at the AISC steel manual, I found that that shape has a nominal shear and a nominal moment that is more than just adequate for this member. So it made me think, like, could I use a smaller beam size? But the truth is that the selection of the beam was chosen because of the deflection. So I hand-checked the deflection of the beam and of the W18 by 40 beam, and it could withstand a deflection just slightly greater than the deflection that this beam had to encounter according to RISA. So I checked this for multiple beams, girders on the roof and floor, and then I also did columns. But columns were more so like the axial load rather than the shear moment, and found that they're all adequate enough, so these W shapes, I would like to say, are accurate. So then RISA gave this 3D model, so my future work is to convert this 3D model to RISA 3D and then focus more on the lateral loads and the bracing, and then after that I will be able to perform a cost estimate. And now I'd like to hand it off to our water resources engineer.
All right, thank you, Emma. So the first thing I'd like to do is reiterate what my scope is, what are my objectives that I'm trying to achieve with my designs. So the first thing I need to do is treat my stormwater runoff, and I do that in two ways, through reducing the total spent solids and removing nitrogen from that runoff water. Next thing I need to do is infiltrate 1 inch of runoff and then regulate how much water I actually discharge from the site. So before I get into my actual BMPs, I would like to show how I adjusted to the new parking lot design that Leah mentioned earlier. So as she mentioned, we chose that second parcel, which means that all I had to do was increase the size of my detention basins and other facilities, and then just shift everything over a little bit. But overall, not much has changed other than sizing. So in order to execute the actual scope, I have a 3-step delivery method. First thing I did was identify the constraints of each BMP. Next thing I did was identify a design methodology. Typically this methodology was from the Crown Boyd Ordinance Manual or from like an EPA website. And then the third thing I did was iterate that design so it meets all the constraints. So the first BMP I looked at was the wet detention basin. Some of the constraints was that I had a maximum allowable discharge from that facility, and I had to estimate where the water table was. The water table is likely to be where those wetlands are in the northeast corner of the site. However, that can really fluctuate, so I didn't really want to dig too deep to the point where I was taking in water from the ground. To actually design the basin, I sized for 120% of the storage volume. Next thing I did was I selected an outflow structure using, at first, mainly arbitrary numbers to decide how much head creates a certain outflow. Next thing I did was a level pool routing, and fourth, I iterated that design. So I redid step 2 until I found a good outflow structure to discharge the water below that 0.78 cubic feet per second. And figure 5.3 here shows the inflow hydrograph and the outflow of that orifice structure, the outflow structure that I selected. And as you can see, it is below that 0.78 cubic feet per second. So to the actual geometrics of the basin, due to space constraints, I had to choose an L-shaped basin. And some things to note is I placed a maintenance ramp here that was required by the ordinance, and I, in communication with Leah, I made it match up with the parking lot, so let's say a maintenance vehicle can get in through an access gate here. Next was a 6-foot high fence, and then because of the unknown water table, I did add an impermeable geotextile layer under the entire site. Each one of these contours represents half of a foot. So a cross-section of the detention basin reveals more of what I just said. We have a 6-foot-high fence, and for safety reasons, we have these level 6-foot landings here. So that's if someone falls in the water, they're not going to sink straight to the bottom, and they will just be on this landing. My next facility was the vegetated swale. So some of the constraints I had to work with were maximum allowable side slopes, and then just fitting it behind the structure. And this is placed at the low point of all the contours. So it's to the very far right of the parcel. It's the low point. It's going to capture pretty much all the water from the other BMPs. So this had to be sized for the entire site. And the design methodology was identified in the Crown Point Ordinance Manual. It was a 10-step procedure that I followed, which involved iterating and finding, selecting a cross-section that meets both the maximum flow requirements and the maximum velocity requirements for that vegetation. My next BMP was a permeable pavement, and I decided to place these permeable pavement spots on parking spots. I didn't want to place the permeable pavement where trucks and cars were going to be driving a lot. That would add a lot of fatigue to that pavement, so I just placed it in the parking spots. As you can see, they're all placed at the far right. Again, that is the low point of the entire land. I don't want to do a whole regrading because that would add cost. The cross-section of the permeable pavement includes 3 feet of 3 feet of storage media into the ground with 40% of void space. And I did consider using a perforated pipe to go under this void space. However, I wanted to satisfy the infiltration requirement, so I left no pipe underneath so that way the water would hopefully infiltrate into the ground. My next BMP was a bowel filtration system. This system is intended to remove nitrogen from the water. And in using some EPA guidelines, I found that there's a maximum 10-foot spacing of these perforated pipes that go under the facility. So if we look at the cross-section, the facility includes an upturned elbow, which means that the lower area is going to be saturated storage media, which is where anaerobic digestion is going to occur. And then there's a moist area above it, which is where aerobic nitrification is going to occur. And this is going to produce nitrogen gas from that water, which is going to remove it from the actual water. Some things to note is that the storage media does include some newspaper, which is kind of funny. I found a study that decided that newspaper does remove nitrogen from water. My final facility was the sand filter, and this BMP is located just to the right of the structure. And as you can see, it takes rainwater directly from the downspout of that roof structure. That water is going to be routed into a flow splitter box. During large storm events, that water is going to bypass into the vegetated filter strip. But for the average lower level storm, that water is going to go straight into the sand filter. As you can see, the water enters the sand filter, and it's going to create a head across the sand where it's going to infiltrate through the sand and into these perforated pipes. If a lot of water gets in, it can go through these holes in the orifice structure too. And this is going to remove total spent salts from the water. This is another view showing the other section of that sand filter, and it shows the perforated pipe underneath that sand filter media. So in the future, I need to adjust some of these designs. BMPs such as the sand filter and the bowel filtration basin will require a little bit more hydrology work to actually size those pipes and orifice structures, especially for that flow splitter box. That's something I'm going to be focusing on. And after I do that, I'm going to quantify everything and produce cost estimates for the actual construction and for the maintenance of those facilities. All right, thank you guys for listening. I'd now like to open the floor for questions. Yes.
Okay, let's just start with the first one. So if I look at the parking lot layout and the driveway or ingress point to the left, it seems to be so close to Merriweather Street. So what's the distance in here between the Merrill Street and that first drive?
You're talking right here.
I'm talking about the drive.
Right here?
Yes, that drive there, is that,
I actually do not know the distance of that. I do, okay, I do remember looking that up. I don't remember what the distance was, but I do remember having to set it back so many feet from the roadway. I can relook at that though in my place too.
just make sure, because they don't allow so close to a main road to have a driveway, if it's not directly on the road. Because otherwise you don't have enough storage. Like let's say you have 2-3 cars making a turn in here, otherwise they will be blocking the Merrill Street in this case.
I remember when I was drawing this in Civil 3D, having to like set a length of a line to like from like right here to like right here. I do remember having to size that, but I'll relook into that. I could have sized that wrong. Thank you.
Thank you. And Maddie, you showed us a manufacturer's like chart. Believe me, I have no clue what I was looking at. So can you explain that chart?
Which, for the manhole?
The manufacturers, like the ones for the inlets. This
Okay.
one.
So for the inlet, this is just showing, like this is just a plan, and then these are just different cross sections. So the main components that I looked at for here was the open area of the grade, which is important for the sag locations, and then the length and width of the grade in my other calculations.
Okay, so that square is more of the grade plan view.
Yes.
Okay, and these are the cross section. Okay, thank you.
Yep.
Now, Emma, you know my question, yes? So because I picked on Addy for like that, having like a 35-inch deep beam or gather, and now yours is what, 62 inches plus 6 inches of a concrete there. Can you go back to that drawing? And look at that in there, like on the upper left-hand corner. So you have W24s by 62, correct?
Yes. So each floor will be 14 feet high. So like Addie said, it does have enough clearance. It does seem very thick, but
It is very deep. So this is like 5.5 feet.
It's 24.
No, the 24 is the weight, correct?
no, the 62 is the weight.
Okay. Oh, am I reading this one?
Yeah, like last time my beam was a
The
W
62
12
is
by
the
35.
Okay, 62 is the, okay.
So that you have a HVAC of 3 foot.
Okay. Okay, good. Now, I know, and this is a long time ago, but you guys always can have a constraint in RISA to have, for example, the depth not to exceed like 18 or 24 inches or so. Okay, that answers my question. I was reading this. That's it for me.
So I have some questions. So Leah, I think it was on slide 4, where you showed like where you moved the roadway north.
Oh, this is the intersection aerial.
Yeah.
This one?
Oh, no.
This one?
That one.
Okay.
Yeah, slide 6, sorry.
Yeah.
So is that, you said like, I mean, is that building still going to be okay, or, I mean, it's really close?
It's probably not going to be okay.
Can it-
That's the reality. They're not going to like that. But this was after, I think it was actually Professor Wright who mentioned that last semester to potentially that you could shift it a little bit so that it's taking up a little bit more space on our property. This also, obviously, then there's like this huge gap here. The engineers will have to figure out how to do that. But previously it was like cutting half this building, so maybe we only have to ask them to remove this garage of that building.
Something, yeah.
I also don't know what that building really is. I tried to get like a Google Street View, and I really couldn't figure it out.
Okay,
I don't know what they do.
okay, thanks.
May I Leah, did you consider, I know like the city of Crown Point in steroids for like roundabouts. they have roundabouts all over the place,
Mhm,
right?
yes.
So did you consider that instead of like a segment like intersection?
I did not really consider a roundabout, mostly based on my skill set. Meeting with my advisor, in my meetings with my advisor, I just never felt like I had the skill set to be able to implement a roundabout. I also think that with a roundabout, like thinking back to like Andrew's systematic drawings for his team, it like took up even more of this space, I feel like. So I did not include that. It could be an option, but I don't think we'll be going forward with the roundabout.
Thank you.
And then Maddie, so you mentioned that the energy gray line had to be below the ground level?
Yes.
There's no freeboard requirement?
There is 1 foot of freeboard. I just generalized it so that
Oh,
it just doesn't, you don't want to have surcharge.
okay, but you're going to design it with 1 foot of
Yes,
tall?
I have designed
Yeah,
it.
yeah, okay, thanks. And then Todd, I had a couple of questions. For your permeable pavement, you said you didn't want drain tile because you wanted the infiltration,
Yeah,
which makes sense, but did you consider an elevated drain tile?
I did not consider that,
So I
but
mean,
now I think I would.
yeah.
I think that would make sense, because if it fills up too much,
Right.
you go
You
through
still
that
need something to.
perforated
Yeah,
pipe,
yeah.
and then I'll still get some infiltration.
Mhm. Good. And then on your level pool routing graph, I noticed
Yes.
like the outflow and inflow are pretty much equal all the way up to at the start of the curve.
Oh, yeah.
Is that realistic, or I mean, as soon as the water, it looks like as soon as the water comes in, it's going out.
Yeah, that's true.
Yeah.
So I could adjust it, just changing the outflow structure again. I think that would be more realistic.
So that's
Yes.
like an artifact of what do you think? Like why is that? Do you know, like why?
It's because the outflows are sized to be super high at low heads, which
Okay.
looking back at it now, I think that's probably unrealistic. However, I could adjust it so that I could probably find some online and then build it off of that and build a new outflow structure. So at higher heads, it's got super high discharge. So
Yeah. Okay.
yeah, that would probably be better. Thank you.
That's all.
Okay, what is it, well, when you're standing there, can you go to the cross-section of the swale?
The swale, yes.
And what
Here, this is the vegetative swale.
what is the slope here on the side?
It's a 3-to-1 slope. That is very tiny.
Okay. I couldn't read it, I didn't know
Yeah.
if it made sense or not. All right, let's talk about the roadway stuff. I'm not familiar with the design standards for a 30-mile-per-hour road in Crown Point. Those curves seem kind of sharp. Are those super elevated or not?
There is no super elevation. So actually for a 30 miles per hour road, given the NDOT standards, which is what, when there was not enough Crown Point standards, we used instead, 250 feet in the radius is what's actually a minimum. So doing 275 is surprisingly actually allowable and above moderation, or I guess minimum. And it looks very sharp. I do feel that as well.
No, I'm just, like I said, I'm not familiar with it.
Yeah, no.
So if you're saying that it's fine. In general, the water that's being collected in inlets from the roadway, is that all you're collecting?
Yes.
So when someone does a new site or our site, the water where does the water from those go? Do they all have to go on their own site somewhere?
That is out of my current scope, but it could possibly run off onto the road, or if there's anything preventing drainage on the road in between the sidewalk, because there is a strip of land between the sidewalk and the road, so there could be something preventing it there. But I
So more of a, what do you think kind of a question?
I think,
Do you
Yeah.
think it would be a good idea to increase the size of the road?
yes, it could
Capacities,
be feasible to increase the size. I just have not taken that into consideration yet.
Okay, I know we have scope, we were told to do it, but now I'm asking, all right, can we think outside the box? Is that something that should be done or could be done? And is it as simple as you get pipe here? I think that's enough. Thanks.
All right, so a couple of questions, one for Maddie.
Yeah.
Going back to the grates on that. And this is maybe just a question that I'm interested in, it doesn't need to change or anything. But that would be like a flat grate, so when the water comes over, if it deposits things on it, it may clog it,
Yes.
right? And so, like in my neighborhood, it has like the flat part, but then it has like a vertical open, for like the overflow in case the grate gets clogged. Is there, I guess, a benefit for just having them all flat as opposed to kind of having the flat and vertical?
Yeah, so that was one of the alternatives that I did consider last semester, but because in the drainage, in the design manual that I use, the benefits of a combination inlet is what that is called. There's not enough flow in our system to necessitate that. And then because there is clogging assumed at the site inlets, I did take that into consideration as well in my design.
Right, thank you. And then on the transportation side, we'll go back to your parking lot. I'm always picking on your parking lot. So for this one, it's more envisioning how people are going to get to the building from the different spaces and to the entrances. So Emma has kind of the stairwells, which I think are the entrance locations for the building. So as far as like, I guess sidewalks or defining like pathways through that, especially if you start on the way kind of left and then want to walk over to that. So I don't know if like the sidewalks or the paths would be part of your scope or not, but maybe looking at that a little bit, especially at the entrances. So moving a couple of the spaces away and having the flow.
Yeah. I've not really thought about pedestrian movement, to be very honest. Just thinking right now, my thought would be if you're parked here, it might actually be quicker to hop onto this, it's kind of hard to see, but hop on this sidewalk and go like that. Because I believe, I mean, correct me if I'm wrong, but the elevators and stairs are like here and here?
Yes.
Okay, yeah. But that is not the most practical.
Yeah, so just having a little bit of like how would they go, they walk around, or, and maybe more on the entrances, right? So,
Yeah.
so that they don't have to walk around the cars and that. The last thing I have is back to you're going to get the extra lot, right?
Yes.
Set up, and so that extra lot isn't really going to be financially advantageous, right? It's like an additional cost. So do you have an idea of how much additional cost or that would be? And kind of like in proportion to like what the other partial development is? Or if not right now, maybe as part of the next step?
Yeah.
Can you break it down?
Yeah, part of the next step could be like, finding what the cost of that additional would be. Yeah, I had not taken into account like the land cost. I think that might be because we didn't like have to like pay for it when we were given the site to begin with. So,
Well, maybe to view it like, if you develop it for the parking lot, then the owner can't develop it, or the city's not developing it, like for, I don't know, if they tax parking lots, but like they aren't gonna have that development be like, so there could be like some cost shifting in there.
I feel like that's something I would definitely want to like look into, just using like online resources. There's definitely some like article out there about it. All right, good.
200,000 an acre.
200,000 an acre? Okay, wow, okay, so that's 400,000, guys. That's all right, thanks, Skip.
All right,
Okay, thanks.
that's all, thank you.